Good morning, everybody. Starting here in 1 second. All right. So yesterday I mentioned, if you were in my session yesterday, about not knowing any good tech jokes. And somebody sent me a pretty good one yesterday. At least I think it's a good one. Why do hippies prefer Jason payload to soap? Because they never use soap. This is another good one, too. I hadn't heard this one yet, surprisingly, because it's one of the better ones. A SQL query walks into a bar and sees 2 tables, walks up to them and says, "Can I join you?" Yes. Tech jokes are tough. That was a good one. All right, let's clear this out and switch over here. So like I said, good morning. Welcome back. Who was here in my session yesterday? Well, that's good. Repeat customers. Good, good. All right. This is going to be hack-proofing your modern web applications. I'm Adam Tuliper with Microsoft, technical evangelist, and I like doing web, gaming, and security stuff. And so today we're going to be talking about security stuff. It's always been a passion of mine. When I started when I was in college and switched majors to computer science many years ago, got into a lot of reverse engineering, and I thought that my career path was going to actually take me down writing software protection mechanisms to stop people from pirating software. And it just so happened that a company like 0.8 of a mile down the street from my house had different plans for me, and they made me a good offer, so I started there, and it kind of left me going more towards the web world. And so I've been kind of there ever since and love it, and just watching how things have grown, trying to hack around things back in the day like what we take for granted nowadays, Ajax, and doing dynamic reloads on web pages, and trying to work around ways to get it to work in the past. And I remember spending like 2 weeks on a technique to do essentially TCP through browser, remoting through a firewall to another destination server that was supposed to be able to work through remote object instantiation through the browser, through VBScript. You could use COM and create an object at a remote IP address. Getting all up and running and being like, this is amazing, getting it working, or thought I got it working, spending like 2 weeks on it, getting all the Windows servers configured and working with servers across the street. And then I was trying to remote create the object. All the networking was set up and it wasn't working. Contacted Microsoft at the time, and the guy goes, yeah, let's see here. The second parameter is an IP address. Oh yeah, it looks like we never implemented that. Documentation said it weeks down the drain. So watching how the web has developed over the years has been fascinating. Now what we're going to do today is talk about kind of a handful of the major attacks. The way I like to talk about this talk is there's a ton of content to get through, and we may or may not get through it all, depending on questions, depending on how things act for us. But no subject is more or less important than the other, so I want to get through a lot. I don't expect you to remember everything. Please, what I want you to do is just keep in mind as we're going through demos, think, could that happen in my web application? And if you answer no to everything that's here, kudos to you. But hopefully you catch a couple things in here that make you say, you know what, I need to write this attack down and grab the slides afterwards, do a little bit more research into this, and go and fix my application, because many applications are broken. So we're going to have a broken app. We fix it through the various attacks. And then I just want to briefly mention scanners. If you use security scanners in your enterprise, it's good to get kind of the low-hanging fruit. The problem with scanners is it's a false sense of security. I've seen websites that say scan 5 times a day by whatever service. And I go and I do the simplest attack that we're going to look at next, and boom, it happens. So be very cautious about scanners. Categories. You'll see these charts change all the time, and depending on who runs the studies, but you'll see a couple of the common ones that pop up to the top pretty often here, like cross-site scripting, information leakage, SQL injection, some attacks that have been around for a long time. So you might look at something we're doing today and say, isn't that kind of an old attack? And yes, it might very well be. But the fact of the matter is they're still very much used today. I like to talk about JavaScript frameworks. We're not going to concentrate on any particular framework going through this, but I just want you to know they're all vulnerable. Somebody once said to me, and he was a pretty skilled guy, says, yeah, but I use jQuery, so my JavaScript is secure. And that is completely false. If you think that you use Angular, for example, and that your JavaScript is secure, if you look at something like, let's grab this URL here because this is a good one if you use Angular. Mustache security, scroll down, injection attacks. With a simple JavaScript trick, one can break out of this non-sandbox and execute arbitrary code in window hosts and other objects, and then they go through a whole bunch of ways that folks can do this inside of Angular. So just because you use a framework does not necessarily mean that you are safe. It's important to understand how the attack works and how your framework works. All right, first we're going to look at SQL injection, still the most major attacks on the market. It's a simple attack, because the gist of it is that you're taking control code and injecting it into your data channel. You have essentially this control channel, which is meant for code that is supposed to do actions, and then separate from that should be this data channel, which is just your pure data, shouldn't affect anything. And so the idea is you get a command that gets altered, like select star from users where username equals Mary, and instead of using Mary, somehow the attacker has input additional parameters here, maybe a closing quote, a semicolon. In SQL, what happens when you add a semicolon? You create multiple batches that will get executed, right? You can send 5 SQL queries over in one line separated by a semicolon, and they will execute as 5 separate batches. And so in this particular case, an attacker sends over maybe a closing quote, a semicolon, delete from users, and dash quote, which essentially comments out the rest of whatever they were doing server side. And then with these 2 queries here, select star from users, and then you run that, and then you delete the users, and then it doesn't matter what you have after that because you just deleted all the users in the database with a perfectly valid SQL statement. How is this exploited? You'll see many, many variants here. Here's a couple of the common ones. URI tampering, where something goes across on the URI or URL, and that gets read in, and that gets turned into a SQL statement without checking it, or without properly parsing it, or without properly passing over the right way, which we'll look at. Another way is parameter tampering. Right on the web page, you just enter something, and that's the technique that we're going to look at today. And there's other attack vectors you don't think about quite as much. Maybe something like cookie tampering, where you take a cookie that's stored on your system, and you fiddle with its values, and then you send it back to the server, and the developer never really thought about it because it's a cookie. I'm really sanitizing its values. It's a cookie. I set it. I'm reading it. The browser controls it, right? Wrong. So it's possible to do injection through a cookie if your code is reading values from the cookie and sending it to the database. Is it an old attack? Yes. 17 and a half years to be exact. This can affect old and new code. It is extremely common. There was a major attack fairly recently, and they happen all the time. TalkTalk hack. According to a recent study by Verizon, 19% of all attacks are SQL injection based. So let's look at some demos here. Now, what we have, see, they thought it was funny. You guys did too. Let's set this to my startup project, and let's run this. And we're going to go over to this guy. So we have this legacy-looking application, but everything that we do here is going to fit into the realm of, doesn't matter if you developed this 10 years ago, doesn't matter if you developed it yesterday. We've got a basic search interface here. I search, I return some products from the database. Dog collars, goldfish, etc. Now, I'm trace logging all of the information here, so we can see the SQL query. And it looks like this. Select name, description, keyword from product, where name is like. And we just add a % sign on each end, right? It's essentially this wildcard query, or keywords like, and then we order by name sending. All right, well, what happens if I just put in a single quote or maybe dash quote? Incorrect syntax. Problem, SQL error. Now, if we look at our query here, right, we've got incorrect syntax in our mod operator because we have an invalid query here. There's our strings. And here, right after our string, we just have a dangling % sign. So we get an error on our SQL statement. The attacker sees this, and they say, oh, wow, I can inject something and break something in your code. I see this happened on, this is a SQL exception, so this wasn't anything like on the parsing side up front. I'm breaking your code. Now, what if you don't have like an error page here? That's okay, because you can still profile databases using like, I'll do this guy here. Wait for delay. Essentially, it's a, can you guys see the font okay in the back? Thumbs up if it's okay. All right, it kind of fades off as you go back. I should have said thumbs down here. We'll go a little bit bigger. Wait for delay, it's essentially just like a sleep for 5 seconds. So search bad, and notice we have a delay now. There's no errors getting written in the database, but we know 1, 2, 3, 4, 5, and if I change it to 10 seconds, I'll see there's a change in the response time to 10 seconds. So I have been able to affect the execution on the server by breaking out of the data channel into the control channel. And if we look at the SQL statement here, there's SQL statement number 1. I closed it off with a quote and a semicolon, wait for delay, and then I just comment out the entire rest of the SQL statement. All right, so well enough. Once you know that you can do some work there, one of the very, very common tricks that you'll see is attackers will not save, Control A. Use a union with a select to try to profile the various columns that are in your database to see what kind of data types there are, how many they can work with. So select 1, 1, 1. And there's quotes around each one. And the reason is because a quote around the 1 is a pretty convertible data type. Right? You can go back and forth between like booleans, integers, characters. So this works across a whole variety of data types. So let's search bad. And now we see that we've got our results here, 1, 1, 1, that have been put into our results. So we've got our search results, and now we've just added on a row on top of that. Now we know what our format is. Now we know how many columns that we have to work with. Once we know how many columns we have to work with, then it's just a matter of kind of profiling the database. Union, select name from sysobjects where type equals u, so a table. Now we have all the names of the tables in the database. Once you do that, right, it's more just a matter of profiling down a little bit more and saying, okay, I've got the names, why don't you give me, oopsie, messed something up there. I know what I messed up there, but I didn't copy the right query. And so that's actually a good time to talk about this. In the project that you can download, you will find there's a SQL injections.txt. So if you're wondering exactly what these commands are, you'll find them right in there. Now we've got table, column, customer, city, customer, customer ID, customer, default credit card number. Yes. So you can kind of imagine where that goes after that, right? With a credit card number. And I've seen production sites exactly like this. We just grabbed the credit card numbers from the database, basically made that our result, and hey, it's displayed in our data grid on a web page for us. Yes, easy enough. So typically, if I go to order something on the net, I'll do something like that, -- quote, and see what happens. And literally, there's a site years back I was about to order something expensive on, and scanned by whoever, and I just did -- quote, and I got an error, and I just contacted them, and you might be open to some sort of attack here. You might want to check with your developers, and they called their developer back from vacation, which he was not very happy about. Then he implemented a change which took down the other websites that were on their hosting provider. And then their hosting provider said, if you don't fix this, we're going to take your website offline. They did a ton of e-commerce online, all because they've got this little SQL injection bug, and there's a product person internally that freaked out and called them back from vacation to fix it. But it's a really important and real attack. Now, I have search better and search best here. It should really be search better 1 and search better 2. And you notice that when I do search better 1, search better 2 here, nothing happens. And let's talk about what the problem is behind the scenes. So our product search page, and the same stuff, even though this is kind of a legacy web forms application here, this same stuff applies to virtually whatever technology you're using. So load products inline SQL, what do we do here? We're just really we're creating a SQL statement here. Let me maximize this guy. Select name, description, keywords from product, and notice, even though we're using string.format, we can easily just break out of our control channel here our data channel. So for example, if the user enters in hello, quote, dash, dash, we've just broken out of that. So it allows easy injection into there. The two fixes for that are either three. If you are really limited into what you can do, Gesundheit. If you are really limited in what you can do, you can try whitelisting everything that's coming over here. And you can say, we are only allowing certain values. For example, using a regular expression to just replace anything that's in there with A through Z, 0 through 9. That's saying, I can't touch my database here. I can't touch much of what's going on. But on the front end, I know I can at least kind of use a regular expression to get rid of anything but alphanumeric. Next down the line, parameterized queries. It looks very similar because we have this string-based query here. But notice we're using @product name. This does not allow the user to break out of the data channel because we have our query here. That's all of our control code. And then separately, we're passing in an actual parameter name. We're saying, here's a parameter name, @product name, and passing the text for there. So this is a parameterized query. This is safe, and this is what ORMs, if you are purely using an ORM out of the box, like Entity Framework, that's what they do behind the scenes. You can still run into trouble if you are doing your own custom SQL queries behind the scenes, like Entity Framework, for example, will allow you to run raw SQL queries. So it's possible that you're misusing it as well. And the last one here is a stored procedure. A stored procedure is a form of a parameterized query. This call can be misused, so you have to be careful. Again, you're keeping your control code and your data channel separate. So here's the stored procedure name, and it takes two parameters that I'm passing in completely separately. But I've seen this in production cases during security audits misused because they're like, well, hey, we use stored procedures, so we're okay. But when you look at their code, and when they're using a stored procedure, they're really user input right here inside of the string. So even though you're calling a stored procedure, you can still misuse it in the way that you're calling it. So you want to make sure that all of your calls are parameterized. You're keeping your parameters and your queries separate. No dynamic strings. Escape or whitelist your input. Really easy, low-hanging fruit method to just use a regular expression, filter out what's in your statement. Audit your table permissions. We'll look at that in a second. Use an ORM. And on the whole escape whitelisting input side, I had somebody years back said, I have a routine, and I strip out any quotes from what comes in, so I'm protected. And we were really proud of this technique. And I said, all right, well, what happens if you are, for example, let's say you're passing in order ID equals 5. And let me just zoom in on this so you can see this a little bit better. This, we'll do VS Live. All right, so order ID is equal to 5. And I said, well, what happens if on your query string here, excuse me, your query string, you just pass in a semicolon and say, delete from users. It doesn't involve any quotes, and they've just deleted all your users. You can kind of see the wheels turning. So simple like string replace routines are not a be-all, end-all. If you're using something like dynamic SQL, that is one of the most troubling points that you find that people have because they say, well, we need this ability to control our code in a dynamic way. And there's various ways of doing it. There are literally blog posts out there this long with some great techniques. We'll just talk about a couple things real basic here. If you need to filter out, for example, maybe you are optionally passing in customer ID. You could do something like where customer ID is equal to the pass-in customer ID, or it's null. You can use dynamic order bys using rank, and I'll actually show you a demo of this. Let's go look at our queries here, and I want to point out that in the project that you can download, let me unmaximize this guy. In the very first thing under solution items here, you'll find all the queries I'm about to show you, as well as some additional ones that we're not going to go over today. For example, like encrypting code with a passphrase, encrypting by certificate. The permission checker script I'm about to show you is in there. So definitely check those out inside of the solution. And first, let's go ahead and do Let's do a dynamic where clause first. In calling this, the idea is we need a way to dynamically sort our results here. Maybe we want to change city, maybe we want to do it on state. And this a lot of time maps to what you'll see like a data grid or something on a web page. You click on a column, you're passing that information over to the query, to the database side, and you're dynamically sorting on that particular column. Sometimes you'll see people that they do this on the server side only. They don't go back to the database server if you have a small number of rows. If you have like 5 million rows in your database, that's not very feasible because you're loading them all in the memory first and then sorting them, and then that's a lot to hang on to the server side in memory. So in this particular case, let's look at how we can ask the database server to order these for us in a dynamic way. We want to be able to pass in a field. Maybe think about that as being the column that you click on a web page. You have a data grid. You click on column 1 or 2 or 3, and that will allow you to sort those columns. The entire results from the database, not your 10 that you're viewing on the web page. And so this order by, we can use this function called rank. And let's go ahead up here, because you'll notice that we're saying rank my results, essentially give them a number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, order them by city and zip, and then number them. Essentially order it by name and give those a number. Order it by name descending and give it a number. And down here, you'll see those results. So using the rank function, that's kind of what happens behind the scenes. If you're saying city zip, these are the order of your rows. If you're doing last name, those are the order. Last name descending, these are the order. And you can just pass that column in and dynamically use that down here. Order by case, so when you order by 1, you're going to rank by city zip. When you pass in a 2, you're ordering by name, ascending, 3, descending. And so we can easily just, whatever they pass in, maybe we want to sort on a 2. Now we should be sorting on this column here, 1, 2. If we do it by column 3, we should now be sorting on this one, 1, 2. So we don't need any dynamic SQL to have dynamic-like queries here. That's just one example. Another one is when we use exec, this is a very common case. You'll also see server-side code. Stored procedures, exec, some dynamic string that they've squashed together. Or SP execute SQL. SP execute SQL is not bad. A lot of times folks will flag this as being something that's dangerous, and it can be potentially dangerous. So I recommend auditing all locations. We'll talk about that in 1 second. But the thing with this SP execute SQL is it allows you to do parameterized queries. Not a lot of folks know that. You can do the exact same thing that you did on the client side by selecting, you give it a SQL statement, and you give it a parameter. So select where first name is like our parameter. And notice we're not squashing in our data channel code here, our parameters that the user's using. We're doing a separate parameter passing in, giving it the name, and giving the SQL statement. So this is our control code. This is everything in our data channel. It properly encodes. We're good to go. So SP execute SQL is not bad. It's actually good because it inherently allows you to do parameterized queries. There are other things you want to watch out for example, like truncation attacks and making sure that your buffers are long enough. I have a couple of demo queries that are included in the project. But exec, when you use exec something, you cannot do parameterized queries like that, so avoid exec at all costs. Now, another one here that you'll find in the actual results in the project is a permissions checker script. With permission checker, this is I can't really emphasize this enough. Use a permissions checker on your database. Use something that's auditing your table permissions. How do you know that the user you're running your database as? So for example, in this case, we're going to create a login called Mary. It could be web user login. It's the application that your web application, it's the user your web application is running as. And in this case, I'm just going to create one. But as of SQL 2005 and up, what you can do is you can impersonate a user. So when you execute a SQL statement, you can say, I want to do this in the context of Mary. And now go ahead and give me all of my permissions back. So we can view this in a nice table. So we look at permissions, we grab a couple of them, and then also at the end, we're just going to query, assuming that you're not using encrypted stored procedures, we're just going to query syscomments to look through, to parse the actual text of the stored procedures for just some dangerous strings, like look for XP command shell, look for, this allows you to execute a command on the server. SP execute SQL. So let's go ahead and run this. Not turn down my volume, but run it. All right, there's Mary's permissions. If we evaluate these results, Mary has select on order line and order and customer. Mary has delete on order. If I'm not auditing permissions, how do I ever know that this is invalid or valid? So you must audit your table permissions. Sit down, have a meeting with somebody. Are these the proper permissions? Should Mary or web user or whatever be able to delete from customers? Look at everything that Mary has permissions on from an execute standpoint. Should Mary's account be able to execute all these stored procedures? And lastly, when we look for things like SP execute SQL, what stored procedures are actually using that? Again, we're just kind of parsing the text, so if you encrypt them, you're not going to find it, but it's kind of an easy way to search all these stored procedures that are not encrypted on your system. So check out the permissions checker, audit your permissions, and at least know what the users are doing. Your web application might act right, but what happens if you have an invalid user in a database with way too many permissions and somebody's in another application using that user account where they figure out how to exploit that? So are you safe if you always use stored procedures? False, because you can call them incorrectly. If you replace something like just dash dash and quote, are you safe? No. We just saw the attack on the URL with order ID where we didn't do any dash dash or any quotes. If you have an error page, you're not safe. It might make it a little bit difficult for the attacker to profile, but there's automated tools out there that will try to figure it out for you. We were able to cause a wait on the server side of 5 seconds. So regardless of whether or not there's an error page, we're still able to execute an attack. Permissions will always protect you. False, because you don't know what the other databases coming in are, and you also make sure that you audit your permissions. And parameterized queries will protect you. Yes, they will, if they are done correctly, if they are called correctly, if you make sure that your control code and your data channel are always kept separately and never concatenated together. All right, let's move on to the next one. This is one of the neater ones, because everything nowadays is script-based. Cross-site scripting. In a nutshell, script, and I make sure I have an asterisk here, is injected to page, database, and cookies. There's reflected, there's persistent attacks, DOM-based. So reflected means you're essentially something on the URL. I give you that URL, or you go to it, and it gets reflected back to you and ends up in your page. Persistent, it's something that's stored in the database. It happens over and over and over again. We're going to look at a couple of them. With a cross-site scripting attack, it's just script. What can you do with script? Well, you can access the entire DOM. In some cases, depending on how they create them, you could steal cookies, you could steal form data. And this class of attacks here, scriptless attacks, it falls under the category of cross-site scripting, but it actually doesn't require any script to be able to grab some data, and we'll look at that. How is it exploited? The idea is that your page processes some sort of data as script when the developer did not intend you to do that. That data can come from anything you entered. Same thing like SQL injection. It can come from the URL. It can come from a form field, a cookie. If you're using SQL injection and you insert JavaScript into a database that gets displayed somewhere, maybe I'm a developer and I thought, you know what? I'm going to allow maybe the address for this customer that's entered in some other system to be displayed on the web page. And I don't really think about it containing JavaScript, and so I just display it. Somebody's now used SQL injection to attack the database, and they've now injected JavaScript into that field, and when you display it, it executes it. You can inject tags, so you can basically change the form on there. You can do partial. We're going to talk about the partial because this is a really neat one. And it's extremely difficult to find or parse out all the combinations. There's cross-site scripting cheat sheets that you'll see on the net, which have just mind-blowing ways that researchers have figured to get around various filters that firewalls have and security products that try to filter out some of these attacks. They get a lot of the more basic ones, but there's some really complicated ones out there. Anything that you do in any kind of code that you have in attributes can be dangerous. All right, let's look at some of them. And in order to do this, let me just grab out one of these guys here. All right, let's go to product details. So product details is a low-budge page where you've got just used tires, and at the bottom, folks can leave comments on there. Basic premise, we have it in lots of our applications. The idea is we're allowing some sort of user input that is going to end up on a web page. I don't care if that user input comes from a box, or if it comes from the query string, or if it comes from the database. It's not going to matter either way, and we'll see. So let's go ahead and paste something in here and save this. Let's go back to this page. Let me log in here. All right. So I've added a comment into here. This item is great. The problem is, let's go ahead and inspect this guy. All right, so there's this item is great. There's our date, name, and this item is great. I don't know if you caught what was happening here, but this guy right here is the injected code. That wasn't a real login dialog. This was what I just entered in as a comment. So what did I enter in as a comment? This item is great, and a whole bunch of JavaScript after that, with some references to things like jQuery, although, of course, we can do this in pure JavaScript. That shows a dialog. Now, I made this one orange. It kind of sticks out from the blue theme on the page. The idea is, if you make it look exactly like the login system that's in your web application, how does the user ever know? They're prompted with this dialog. You write a cookie saying, don't ever show the dialog again. You've now stolen their credentials, and the user never knows because it's not something that's popping up over and over again. I've seen a lot of blogs where you'll actually see something like that, or alert as comments. You can tell that their blogs are properly filtering them out, and it just shows up as text on there. What do we do to remedy something like this? Actually, first, before we do that, let's actually look at scriptless. Scriptless is another variant of this attack, and I think this is really neat. Let me load up the code here, what this web page looks like. So scriptless, Gesundheit. Now, in scriptless, we're going to take a tag. It's simply an image tag. Again, we don't care how it gets in there, but somehow an attacker has written some HTML, and it ends up on your page. Maybe it's in your database, URL, whatever. But notice here, it's an improperly formed tag. It's not closed off at the end. It goes to some other source web page here. And now on our web page, we'll just assume, this is a basic demo, but assume that we have some hidden input here, bank account routing, or some other sensitive data that's on that page. If I go ahead and load up Fiddler, actually Fiddler is running here, so we can see kind of the request happening. And let's go to our scriptless page. All right. Now, all we did on this web page was we had a broken image tag that was kind of sitting up on top in the page somewhere. Now let's look at what happened kind of behind the scenes here. Here's our request to our web page. And now notice this guy. There's a request to hacker. Just assume that's some bad, malicious website. And passed into that website on the URL is all of this data here. And we can see bank account. This is all the data from the page. It's the same thing that I show you in the dialog box here. This is what goes over to the page. This is the image, our broken image tag. That is what our image tag source has now become. In other words, this guy right here is just an image tag, and the source is hacker, ? The browser says, these browser guys are good. Browsers are amazing pieces of software. And the browsers try to fix some things for you sometimes. And it says, all right, and this is modern browser running this in. All right, here's the start of your query string. The browser never finds a proper closing tag for it, so it gobbles up the entire rest of the page and includes that in the URL that it's requesting for this image tag behind the scenes. So there is no script here whatsoever. It's an image tag. Right there. There's the actual image tag. There's the ? And everything else that was in the page is now sent over on the URL. It doesn't end there. It ends at the very bottom of your page, and the browser says, oh, that must be the end of the image source. And now the attacker, without notifying you in any way, has just captured the entire contents of your page. So that's a scriptless attack. Scriptless attack does not require any JavaScript, although it falls under the realm of cross-site scripting. Preventing cross-site scripting, for the most part, is relatively easy. It gets more complicated when you're using frameworks, and you kind of have to figure out how those frameworks display data or how the controls you're using display data. You really have to understand how everything displays your data. So HTML encode is the first rule, all of your output. And that can happen through a variety of ways, right? If you're using something like Razor syntax, the @ sign automatically HTML encodes your output, unless you're doing something like HTML.raw, where you're not encoding your output. This particular syntax here, with a colon on there, added in, what was that, ASP.NET 4, .NET 4, where basically these colons will automatically HTML encode your data. You can manually call HTML encode or HTML attribute encode. And lastly, this guy right here was added in ASP.NET. This was for 4.5. They finally added the binding syntax. So if you're doing data binding on a web page, you can HTML encode it just by including a colon on there as well. Avoid dynamic attributes. These are incredibly difficult to defend against. So if you are allowing some sort of user input at some point in time, or database input, some dynamic data that gets displayed, that gets added here, and that becomes the JavaScript that gets executed. It's very, very difficult to defend against there. That's why I always try to avoid anything for inline events that you're running. Web forms validate request equals false. You saw this a lot in posts where folks had like a WYSIWYG editor or something they were doing, and they would go to the net and they would get something like, I don't know, an error basically telling them something like this. Let's go back to the page we were on. I think we can do this on product search. Boom. You've probably seen this if you've been doing web development for a little bit in .NET, ASP.NET. At some point in time, you saw something like that. And that's basically some really rudimentary built-in protection that says if you see a less than sign and a character, the world is ending, stop everything right now. Well, developers would see that without understanding why it was happening, go out to the forums, say, hey, it's happening, and another helpful developer looking for the Stack Overflow points would say, oh yeah, that's easy to get around. You just have to turn off validate request. No, you should understand what's going on behind the scenes. There are various mechanisms in place that will allow you to post what is considered HTML data that can have angle brackets without a problem, as well as most modern plugins, things like that you would use in a browser, can encode on the client side before sending to the server side, so you'll never see that issue. MVC 3 onwards has allow HTML. The MVC equivalent here, validate request, is validate input false. You want to avoid that as well. And anti-cross-site scripting included in 4.5. So there's an encoder type you can specify. Let me show you this in the security. Did I not add this in here? I'm certain I did. Give me 1 second. Did I encode or encode? Let me make sure I'm in the right actual one here. I'm not. That's what it is. I have 2 different web projects open here. There we go. All right. In our web config, we can specify a particular encoder type. Now, there's nothing that's necessarily broken with HTML encoding. The thing is, with HTML encoding, it does not have security in mind. That's not why it exists. It exists to preserve HTML compatibility. So it only encodes, a couple things it understands. The anti-cross-site scripting encoder This used to be in a separate web protection library from Microsoft and was eventually incorporated into the framework under System Web Security, anti-XSS encoder. So you add that, and anywhere in your application that it's calling HTML encode, instead of using what's built in by default, it will now run through this encoder. And this encoder has a different approach. As opposed to only handling like 5 characters, it has a whitelist approach. It says, I realize that only these 40 characters are safe. Everything else I'm going to encode. So it's just a better security approach. You're letting this handle all the encoding as opposed to just worrying about HTML compatibility, which the anti-cross-site scripting one also does. It preserves HTML compatibility, but it whitelists. It's a better approach. Additionally, this is important too. Should you store your data encoded? You should not store your data encoded, but you should sanitize it before you save it to your database. The problem is, if you store your data encoded, you end up with something like this. If the user in their data does an angle bracket, that again gets encoded as this and saved to the database. Well, next time the user views that page and saves it again, it double encodes that and then double encodes that. Anybody ever see that in any kind of production software? A few folks. Back in the day, in production, not just web software, I've seen it in other software like desktop software you run. I'm like, oh, they're encoding their data before they save it, and you could see that over time it got re-encoded. So sanitizing the data you can do through a couple methods. There's the HTML agility pack. It works all right. It's pretty easy to use. I'll show you a demo of that. The only downside that as time goes on, there haven't been any updates to the project in about a year. There's also Angle Sharp with HTML Sanitizer, and I think the last commit on HTML Sanitizer was something like a week ago. So that gets used pretty often. I'll show you a demo of that in a second here. When you're doing like jQuery and you're using commands like .html and .text, understand what each of them do. If you're just using .html throughout your application just to kind of display stuff, realize that if you pass in JavaScript, it's going to process JavaScript. If you pass in HTML elements, it's going to create HTML elements. If you pass in JavaScript to that jQuery function, it's going to execute it as JavaScript. Use text function when you want. I have about a 5 or so hour Pluralsight course on web security, and there are some demos that I go back and forth on where you can actually use HTML and encode it and eventually end up with something, even though you think you're protected against it, that still gets executed anyway. HTML can be dangerous if you are not just passing in HTML. And again, how are you controlling that? Is it anything coming from the database? Is anything coming from user input? Maybe you're displaying HTML with user input inside of there. So caution, always be aware of where you're displaying data and think about how your data ends up there. Can a user, even if they break into our database, can they get bad data into there that can then hack our users? Test all of your controls. Go to your web page and do exactly like I did on this page over here. Say, well, what happens if I enter in like an angle bracket and something? What happens? Know that how your controls behave. Understand if they're going to encode them or not encode them. Not all controls, like for example, if you're doing something like web forms, does a literal control HTML encode versus does a text box HTML encode? No versus yes. Look at your web page. Every area that you are displaying data or using data on your web page, whether you are including it, passing it to JavaScript files, or whether you're just displaying it directly, open up your web page in your IDE and say, all right, where am I displaying data? How is data getting to this point here? Figure out all your different methods that data can enter in there. Can a user at any point do some invalid code that is going to get displayed here? That's always something to keep in mind. It's usually fairly easy to audit a web page. Content security policy is another newer mechanism that you can use to help protect your applications against cross-site scripting. And the content security policy header basically tells the browser to limit what it can execute based on certain rules. Let's go ahead and look at a demo of content security policy. First, let's look at 2 URLs. Close this guy. So content security policy in all modern browsers, Internet Explorer, IE11, all the other modern browsers, for the most part, we'll ignore, I guess, Opera Mini here. I don't use Opera Mini at all. All the other ones here latest versions are all okay with content security policy, which means they will understand the header that comes down. What is this header that will come down? So let's go to content security policy. Content security policy is just a header. So let's look at the first case here. We're going to pass over a header to the browser that says report only. And what report only will do is it's going to evaluate certain policies and tell your server about it. This is good to use as an exploratory measure before you start implementing things onto your website, or even afterwards. Let's clear out Fiddler and request this URL for content security policy. All right. The things that we want to look for here, I want to call out a couple important points. So we have, we're referencing AnyScript.javascript, and also notice that we have some other requests. Now these files don't exist, so they're standing out in red here. But I just want to show you that we're requesting a local script, AnyScript.javascript. Now we're requesting something from some random website, your site, AnyScript.javascript. Also notice that this URL is getting called. That's by design. That we want. And maybe the other ones we want too. Don't let the red fool you here. So this CSP report endpoint, what it's going to show you, let me copy this out and put it into a text editor we can see a little bit better. Here's the URL that this header essentially sourced from. Violated directive, script source self, effective directive, original policy. And so what this does is it reports the status of the current page based on content security policy rules. And we're going to fiddle with these rules in a second to understand how this changes what we can do on our page. So this reports back to some web page you set up. Let's assume you set up a page called CS report endpoint. That is going to log all of this data that you can then evaluate afterwards. Now let's look at what this header will actually do for you. Let's go to our HTML first. And notice on our HTML, we're just requesting your site, and then we have a script off of Microsoft.com. We have our AnyScript.javascript, as well as inside of here, we had inline JavaScript that's getting executed. It's just showing us an alert in the browser. So we have JavaScript coming in through several different methods. They may all be valid. They might not be valid. So here's our little dialog from our alert. Now what we need to do is just enable this header. Let's compile that and launch that. All right, so what we've done is we've now added the content security policy header. Default source for scripts is ourself. Let's see how this changes our results here. Let's clear out Fiddler and request this again. All right. Notice what didn't happen. First off, we didn't get the inline JavaScript alert. One of the things that content security policy will do for you is basically say, hey, inline JavaScript in your web page, we're not going to allow that. Which is awesome because if somebody finds a way to inject it into your page, it's not going to allow it. It basically requires, in this particular case, that this script came from your site. That's the only script that is getting executed. Stuff that successfully came down from your site. So whatever happened in the web page, inline, we're not going to execute, as well as we're not going to include any other references to scripts, like your site and Microsoft.com. So this really limits where we can pull in data from. Or if you want to pull in data from something like Microsoft.com, or whatever your CDN is, for example, your content delivery network, maybe you're using any one of the caches around the world, you can enable those to let the browser, to let the application load those URLs. You have full control over what you can add here. But I highly recommend using that. That's one of the modern techniques that you can use to essentially make sure that inline JavaScript doesn't get executed and sources from invalid sites as well. All right, lastly, in this section here, let's look at the HTML agility pack. This web page is pretty basic, and all we're doing is we're displaying some data here. Let's look at what it does behind the scenes to display that data, and then we'll talk about the problem and look at the solution. All right, notice we have some raw data getting displayed. In other words, whatever's in this text box here, which happens to be some valid HTML and some JavaScript that just shows an alert. So here we just write it out to the page, and then next we call into HTML sanitizer to sanitize it. This essentially uses the HTML agility pack. And if we look at HTML sanitizer, it's some code that's included in the application. The HTML sanitizer sanitize so we can look at our sanitizer here. Let's search for it. HTML sanitizer. All HTML sanitizer does is it uses a whitelist approach. So it says that these particular tags are OK. Sometimes you want to edit HTML on a web page. That's cool. There are perfectly good use cases for that. You are allowing only these HTML elements. So if there's a script tag in there, you're not allowing it. And what this essentially does is it loads it up in this essentially virtual DOM and then pulls out whatever the invalid elements are. So it's not just doing like a string parsing on there. It's actually kind of creating this virtual DOM and pulling out the bad elements. It's a great way to defend against it. Well, defend against what? Something like maybe hey is allowed, but our script isn't allowed. So let's look back at our code. So the HTML agility pack, we're taking our input and just running it on that input and writing it out to the page. And that is what we're seeing right here. Let's inspect that element and let's see what the differences are. All right. So notice the HTML agility pack, we've passed in this invalid string right here that has the bold tag. So here we're just writing it out raw to the web page. This is after parsing with the HTML agility pack. Hey, and then look at our alert. It's no longer surrounded by script tags. It's basically sanitized that for us. So we run our output through there, and it pulls out any of those invalid elements. It's a great thing to do before you save it to your database. It's also a good approach if you want to use it when you're loading your data. So when I mentioned earlier, don't encode when you save it, sanitize it when you save it. Run it through here, pull out the bad stuff, and then you can save it to your database. So that way you don't end up with bad markup in your database that has embedded script tags in there. You might be properly HTML encoding your application, but maybe when you leave the company or in parallel another developer is running a web application and he's not properly HTML encoding the output. So whatever bad data is in your database is getting displayed in web application number 2. It's important to make sure that your database itself is stored in a clean manner. So sanitize before storing. Content security policy we actually just looked at. All right, let's go on to CSRF, cross-site request forgery. This relies on you being authenticated to a website and the attacker assuming you're authenticated to the website and getting you to execute something on behalf of them. And it can be a really, really simple attack, and you might never see it. For example, when you load up your email client, and there's embedded HTML and images and things like that in your email client, by default, what do they typically do? They don't show you it by default. And that serves multiple purposes. One, it tells marketers who are doing special tags, like in image tags in your markup, that it doesn't tell them you're reading the email, right? It stops them from tracking you. That's great. Another thing is it helps stop this attack as well, because what happens when you are authenticated to a website? I'll use a water bottle to represent you. This is you and all of the cookies that you have in your browser. And if you go to your bank, what's your browser do? Your bank sends over all the cookies, right? All the authentication cookies and saying, hey, I'm authenticated with every request. I'm authenticated, here's my token. Now, the bad guy over here sends you some action that they want you to do in the bank. They get you to execute a URL or something. And what happens? Your browser happily sends over your authenticated details, assuming you're authenticated. What does this look like in real life? I'll show you an example. Identifying this attack is difficult because you're not looking for things. With SQL injection, if you're logging, you might be able to see some things that are popping up as exceptions in your web page. With this, it's a perfectly valid request. They're just assuming that you're authenticated and asking you to do it. So it's hard to identify because it looks like, well, yeah, you did a transfer of your bank account, but it looks like you were logged in when you did it. It came from your IP address. I've got this little spoof email that I sent myself here. Because who doesn't like tech books? And this is the best book deal ever. C# in a nutshell. Or you ever see any of the kind of about a month ago was going around, all the spoof O'Reilly book covers? Anybody see those? Everybody's posting them on Facebook, like funny. They were fake. How to coding by Stack Overflowing or something like that. They're just funny book covers. So you receive this in email, and there's nothing wrong with this image here. Hey, Adam, check out our latest ad. Click here for the latest tech deals. All right. Before we do that, let's go back. We can close out permission checker. We're not using that. We're not using that. We're not using that. And if we look in our database, in our tables, just to show you what we have here, let's look in our user table. And at the very end, we have a VS Live user. The user ID here is 127. Now, let's go ahead. I'm just going to do something here to reveal some of the kind of the magic behind the scenes. Let me log in. So now the attacker that sent you this email is assuming that you're logged into your bank or whatever website. And they send you this email, and you're like, oh, cool, a tech deal. And you click on it. And what happens? It goes over to the website, and if they pass over a valid user account, like 127, boom, user 127 was just deleted. You may have realized after the fact because your browser popped open, but maybe they used a trickier attack. Maybe the code that executed this URL was in a very small image tag hidden on a blog that you go to. They use cross-site scripting to get it into that blog, knowing that you frequently post there. They know the blog is open to cross-site scripting. They basically have that in a hidden image tag that you will never see. And every user that goes to that website, including eventually you, when you load up the website, will request that in a hidden image tag. And what happens when the browser requests from your bank or whoever in a hidden image tag that URL? It happily sends over any authentication token that you have as a cookie. And so you never even see this attack happen because they've piggybacked on a couple attacks. So they've sent you an email, they get you to click on a link, it forwards you over to a blog that uses cross-site scripting, and then it has just requested this URL from the website that you are logged into, and it executed that action. So we violated a couple principles here, which you see quite often. We're developers, we do it. The idea is that it allows a request to be potentially repeatable. We saw that it can be embedded inside of an email. It's not the only way, though. You can attack by cross-site scripting. You can do an iframe. We can do an invisible image tag or a visible image tag. What happens when we saw image with source equals, the browser happily requests it. We saw that earlier. So if you pass in that URL in an image tag, it's going to request it, or you can do it completely invisible via doing an image object in JavaScript like the last line there. All sorts of ways to execute it. Preventing, there's a couple different things you can do. The most basic rule that we violated here is that GET requests should not change state. And we did that. We sent over a URL. It was just a GET request, not a POST request. And we changed server state. It should be at least a post, or put or delete, depending on how we're using our API and if we're being good with our HTTP verbs. Keep in mind that forms on a web page only allow get and post, whereas when we do API calls, we can do get, post, put, delete. Unfortunately, when they did HTML5, they were looking at using put and delete when you're doing a form request, but they never made it and only get and post. So you want to make sure that any modifications on your website, the very minimum, happen through post only. Get request should not change state. This is basically part of the HTTP specification. And you also want to try to prevent repeatable posts. What do I mean by that? If you look at MVC, for example, and you have these anti-forgery tokens, well, let's back up one step and talk about what's a repeatable request. If we look at, let's do admin, we'll do user. Let's load this back over here. Oopsie. All right, let me launch my MVC application here. Give MVC some love. All right, now in our MVC application, we have a user controller. And our user controller allows us to load up a user, edit the user. Let's clear out fiddler. And if we submit this request and we have saved some data, what happens on the server side here? There's our get, there's our posts, and then we redirect with our get. So let's get rid of everything else here. All right, so there's our post request. We're asking for a user 7. And we're sending over some data that we're going to modify. Nothing strange here. This is exactly how HTTP works. We're sending over the username and password. It's a GET request. A repeatable request is one that if I take that exact same thing and do it again, will the same thing happen again? And in Fiddler, it's really easy to check because you can just replay and reissue a request. That's a completely valid request. We just overwrote the data on the server. This is a repeatable request, meaning that if you are an attacker and you get these details and you embed them in a simple JavaScript request in a blog, that you could potentially get me to execute this valid, repeatable request. Where the form tokens come in, like these validate anti-forgery token, which also use in conjunction with a HTML anti-forgery token, that uses essentially a two-pronged approach here. It requires that you have a particular form field, and it also requires that you have a particularly formed cookie. And so it uses that data together to basically try to say, all right, we're fairly certain, although it's not infallible, we're fairly certain that this is a valid request coming in. Now, it is possible that the attacker could fake all of this. What makes this more difficult is there's a cookie component involved. So if I just do this through like a pure image tag or JavaScript on in a blog, it's not going to have the cookie component that's also required to validate this request. It makes it less repeatable. It's not a perfect approach, because if somebody is still able to sniff your connection, then they could get all this data and try to recreate it on their own side. They could steal your authentication token and reissue this request as you. These are not one-time tokens. If they grab this entire request with the anti-forgery token and they're able to reproduce it, say, on their machine, they can act as you and essentially hijack your session and do it. But outside of that particular case, this makes it more difficult for somebody to use cross-site scripting to act as you to do a request. So that's what these anti-forgery tokens do. On web forms, you can sign your view state with the session key. Now, that's assuming using sessions, and of course, there's lots of debate over the many, many, many years. Session's good, session's bad. But when you have a particular session ID that's established, you can essentially sign your view state with that session ID. And so when somebody else is logged in or they try it in a future session or somebody that's not you, it's going to fail out because it doesn't have that particular session ID, right? Until you log out, your session times out, you have a session ID. Once you log out or your session times out, that session ID changes. So this is limited in scope of time. In other words, in the future, that session ID, even for you, is going to change, which is good. Because this means that if somebody captures that data and they go back in maybe tomorrow or later on that day, that session ID might not belong to them, and they might not be able to execute this request. Don't turn off enable view state MAC equals true. That's one of the other things I would find on Stack Overflow and blogs where folks would go in and turn it off because they read it on the internet. This will disable some of the built-in web forms protections. This is one of my favorite attacks. This is a variant of CSRF. This is called the one-click attack. And if you have, who in here has any web forms applications in their environment? All right, so a good majority, it looks like. Web forms has some assumptions that it will do. For example, button commands are only processed on a post. Let's actually even put a pause on that. We looked at a case a minute ago where we sent over a request to delete a user. That was this guy right here. Admin delete user. And we just, as soon as this page loaded up, we did that on get. It wasn't a post, we did it on get. And we could easily fix that one case. Let's just save that, set this as default. Now when we go back to this actual web page and we try to delete a user, there's some user interaction here. We say, oh, OK, we need to click on a button to delete that user, assuming it exists. Let's just try a different ID here, like 125. And we would have deleted it, assuming that user ID existed. There we go, 123. So there was user interaction I was able to see, which is pretty good. It's not an invisible attack then. So web forms assumes, we assume if we ever did web forms development, that when you click on a button that's handled in not get, but post, right? On postback, these button event handlers are handled. We also think that view state is processed on post, right? Because view state, you get sent over on a post. And then we also have in web forms page.isPostback. And that should tell us, is this a get request or is this a post request? Pretty simple. Unfortunately, all of those are false. And it allows you to do some interesting things. So let's go ahead and run this page. We have an add user page, just clear out Fiddler. And we're going to create a VS Live 2016 BIP. All right. Is postback is true? Let's stop Fiddler here. Is postback is true, and this user has been created? If we look in our database, there we go, VS Live 2016. So that user's been created. All right, so far so good. Let's look at our add user page here, though. Behind the scenes, nothing in page load. All right. Only when you click on save do we save the user. And we write out this little text here, is postback. We say page.isPostback. So if it's a postback, we should see true. And so far, so good. If we can validate this, although we know it. We can validate this inside of Fiddler. Clear out the rest of the junk here. All right, so here's our post request. As expected, we can look at this nice little web forms view, and we can see all of our data here. What we can do as an attacker, let's assume that you are over at, I don't know, Starbucks, and your website is not protected by SSL, or maybe one page isn't, or you're doing like a man-in-the-middle attack, and you're able to somehow sniff this traffic going back and forth. And all you see is this request come across. Let's look up this and take this URL. Let's treat these separately here. So there's our add user URL. That's what we just loaded. This is the data that was sent across in your request, a post request. There's nothing wrong with this. This is how web forms works. We can see somewhere in here, there's VS Live 2016 and the password that we sent over. There's text password and text user. Let's delete all this and resume capturing traffic. And now let's paste this in. What happened there? Was this a post request that I just did? Nope. This was a GET request. This was something that I could have added to an image tag in a blog somewhere, something that you visit, or in an email, or get you to click on a link. This was not a post. But using a GET request, we were able to trick web forms into thinking it was a post because web form says, oh, you're passing over like view state? This has got to be a post request. And we got page.isPost back to lie to us. Even web form said, sure, that was a post. We know it wasn't a post. We just saw in Fiddler that this was a GET request. Not only did we trick web forms, but we faked an entire user interaction by using the URL. We faked somebody clicking on a button, typing in data in a web page, and then clicking on an actual button. We did the exact same thing on a GET request on the URL. There was a meetup session I did a while back on security, and a guy came up afterwards, and he looked like he just lost his closest relative. And he goes, we do all these financial services websites and for major clients, and he's like, they are all vulnerable to this. The fix is relatively easy, and it's not very invasive. So this was our add user page. And inside of, let's maximize this so it looks a little better. What happens on virtually any like web forms page, for example? We inherit from page. That's how web forms works. Well, we can just change that to some other class that we've created called PageBase. And let's look at what PageBase does. PageBase just basically says a couple built-in rules like, hey, if your view state doesn't exist on the form, we're going to throw an error. Or if view state is being passed in on the query string, throw an exception. There are other ways to do this, right? You could do this through something like an HTTP module. There's other methods as opposed to changing who you're inheriting from. This is just one way of doing it. But we just are including some basic rules here that if view state is enabled and you're passing in on the query string, that's no good. Let's go ahead and compile this, launch it. Not my volume. My function key keeps coming off here. Not coming off, but being disabled. I've had keys fall off my keyboard, too. That's the other type of coming off. All right, now let's go ahead and run this request again. Good. We have now defended against the one-click attack. View state cannot be passed on the query string. Perfect. All right. How much time have we got left? Do we go to 45? 1 minute. All right. So I'm going to fast forward here because there's one last thing I want to show you. I talk about encryption, protecting credentials, which I'm going to show you that in a second. There's information leakage. There's one thing to be aware of. If you search for retail mode, ASP.NET, there's a value you can write into your machine config that forces everything, all of your web applications, to disable tracing and to make sure that your custom error pages are turned on, even if your developers have forgotten it. Why is that a good idea? Because if you look at any search on the net that includes stuff about trace information, and you click on it, you can find tons of websites out there that are misconfigured and dumping out things like credentials and SQL statements out on the internet. You can publicly search for them just using some lines, like I don't know who this website is. Don't take a picture of that because I don't know who it was. That's just by searching trace information and this. So the last thing here in the last minute, let's talk about strict transport security. Strict transport security is unbelievably important. Modern browsers are supporting this. It basically says that the first time you go to a website and Your website should all be protected with SSL, every single page in your website. Strict transport security says the first time you go to that website over a successful HTTPS connection, so they know there's been a successful negotiation and it's really your browser talking to the server, not a man-in-the-middle attack, you send this header down, and that will force the browser on any future requests within our time span here that we specify. Any future requests that aren't SSL, the browser will automatically make it SSL. It doesn't redirect it. The browser says, oh, I see we have received this header for this website. Don't even send that non-SSL request out. We're going to make it SSL and make sure it's secure going across. So it makes sure that all of your requests are SSL based. There's, in the code here, rather than showing it to you because of time, let me look this up in Sublime. The header just looks like this. You'll see this is basically just yesterday I went to Facebook, and I just went to facebook.com, non-SSL. And immediately, because I've already gone to Facebook, it made it SSL. And I can see that strict transport security was used here. So Facebook is sending down this header that says, you know what, your authentication token, your cookie, is pretty safe. It's important. We don't want attackers at the local coffee shop getting this. So make sure that all requests in the future within this time span, which is a huge timeout, is coming over SSL. Really, really important to add, and it's just another header that's coming down. So the modern trend is to make sure that these new browsers understand like content security policy, strict transport security. All right, so definitely check out the slides. I know you're going to forget a lot of what's here. Fill out your evaluations. I'll stick around for a bit for questions. If you have any questions, you can feel free to email me, adamT@microsoft.com. Enjoy the rest of your VS Live, and thank you guys very much.